Hello viewers, Wagadaruna taking you through the story for all-level math contest practice. And this video will be on a compilation of basics of number theory. So like I told you in the previous video of algebra, the reason why we made these compilations is basically for those who are still in O-level and wish to do math contests. This is a must-watch video, and also for those who did not do math contests while in O-level, but they hope to do math contests when they join A-level. So if you are that student, I encourage you to first watch these videos of O-level so that you get on the same line with those who did math contests in O-level, so that when you reach the A-level training, you are good to start. Before we begin the recordings, I would like to display the books we have in stock. For all level, we have Math Power 1 for Senior 1 and Senior 2 work, and the item bank which is complete Senior 1 to Senior 4. Then Physics, for it's the notes are complete Senior 1 to Senior 4, and the item bank is also complete from Senior 1 to Senior 4. So in case you need a copy, contact the author on this contact. Then for L level, these are the books we have in store. There is Physics Math Part 1, Math Part 2, and the item bank for Math 1. Then also Physics 1, Physics 2, and the item bank for Physics 2. So the item banks for Physics 1 and Math 2 are pending, and we are working on them. So those few remarks, I encourage you I can leave you with the recordings so that you can enjoy. Hello viewers, Wagadaruna taking you through the story for O-level math contest questions. In this video, we're going to go through the solutions to the internal O-level math contest for the year 2023, where students in Senior 1, 2, and 3 competed. So these are the activities that will happen in the year 2024. There will be internal math contest, national math contest, then East African Math Olympiad, which will take place in Kenya, then Pan-African Math Olympiad, which will take place in Tunisia, International Mathematics Olympiad, which will take place in China, and Georgia Girls Math Olympiad, which will take place in Georgia. So for these math Olympiads, each country is expected to select six candidates to represent the country. So this paper consisted of 12 questions and with 4 parts. So the first part was logic and reasoning. So I shall go through question by question. So question 1 says, a security guard works for 4 days consecutively, then has the next day off, works 4 more days, has a day off, and so on. So the pattern continues. Today is a Sunday and is a day off. How many days does the guard work before next having a day off on Sunday? So this question was about LCM, or what we call multiples. But still a student could do it manually by saying here it is a day off, then you work for 4 days, 1, 2, 3, 4, you have a day off here, work for 4 more days, 1, 2, 3, 4, then had the day off on Wednesday, 1, 2, 3, 4, then have a day off here, 1, 2, 3, 4, have a day off here, 1, 2, 3, 4, have a day off here, 1, 2, 3, 4, have a day off here, 1, 2, 3, 4, and have a day off here. So that's how you could do it manually. Then you start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So the answer you wanted was 28 days of work. However, the shortest would be using the knowledge of LCM by saying the number of work days until the guards knew Sunday off is a multiple of 7 and 5. So the smallest multiple, which is the LCM of 7 and 5, is 35. So in total, those will be 35 days. But in 35 days, there will be how many work days? So 35, how do you know this 7? So you get this 35 divided by 5 to get the 7. So 35 minus 7, you'll come up with 28. As simple as that. However, if you do it manually, still get all the marks. Then question 2 says, Joe and his 5 brothers are aged in these years. One afternoon, 2 of his brothers, whose ages summed to 16, went to the beach. 2 brothers younger than 10 went to play baseball, and Joe and the 5-year-old stayed at home. How old is Joe? So first of all, you have these ages: 1, 2, 3, 4, 5, 6. Okay, but we say that the 5-year-old stayed at home, so we're going to remove this. When we remove that person, we remain with these ages without 5. So we have 1, 2, 3, 4, 5. Okay, so now we have 5 people. Then the remaining age pairs, which sum up to 16, are only 2 pairs. There is this with this, or this with this. When you add them, you get 16. The rest you can't. But those who went to play baseball are younger than 10 years old, meaning they will be from this. We have this, this, and this. Now, why did we choose 7 and 9 and not include 3? Because if we say, for example, 3 and 7, it means we shall not be able to get a sum of 16 in these. A sum of 16 in any 2 people, because we shall be left with 9, 11, and 13. So the only option is to take 7 and 9 because they are also less than 10 and remain with so we have removed 7, we have removed 9, we are left with 3, 11, and 13. So in these 3, the sum of 16 is only of these 2, 13 and 3 and 13, which is this. Do you know what that means? It means that this remainder will be the age of Joe. So that's what they wanted. Then question 3 says, on Wednesday, 4 trucks drove in a line, one directly behind the other. None of the trucks bypassed any of the others, so the order of the trucks never changed. How many ways are there to rearrange the order of the trucks so that on the next day, no truck is directly behind a truck that it was directly behind the day before? Now here, we would have used factorials. Remember, factorial is about arranging, but because of this condition, that no track is directly behind the track that it was directly behind a day before, it means we cannot just simply use factorial, because factorial means total without restriction. So what we are going to do, we are going to first list all of the arrangements, and all the arrangements will be for factorial. And when we use the calculator, it will be 4 times 3 times 2 times 1, which is 24. Therefore, we are going to first list down all the 24 arrangements, then we can analyze the order so that the no track is behind the track it was the day before. Now let us first arrange. So we are going to first come and say that suppose we label the tracks 1, 2, 3, 4. And those will be the corresponding positions. It means that on the next day, this is that day, then the next day, we shall get the other arrangements. So for ease, we are going to arrange them in ascending order. Let's begin with the ones of 1000s. Those are the ones. Then the ones of 2000s. Then the ones of 3000s. And the lastly, the ones of 4000s. So now it is time to analyze this condition. The no track is directly behind a track that it was directly behind the day before. So the day before is this 1, 2, 3, 4. So 2 was behind 1, 3 was behind 2, and 4 was behind 3. So if you look at this, in this column, these will be crossed. Why? Because here 2 was behind 1, and even here 2 is behind 1. Okay, so that goes away. This is okay because they are not behind each other. But if you look at this, here 4 was behind 3, and here 4 is behind 3 directly. Not that word, directly. So that goes away. Then here still 3 was behind 2, and even here 3 is behind 2. So we cross it out. What about the next column? So these are we only have 2 ways in this column. Then the next, if you look at this 3, there is 3, 4, 3, 4. And here there is 2, 3. And here it was also 2, 3. Here we have also 2, 3, 2, 3. So it goes away. Therefore, you remain with only 3 ways. Then the next, we have 1, 2, which is here. We also have 1, 2, and also 3, 4, which is here. Then we also have here 3, 4, which is here. So they have to be crossed and remain with only 3 ways there. Then the last column, we have here there is 1, 2, which is here. Here we also have 2, 3, and here we have 1, 2. So they're cancelled and remain with only 3 ways. So the total number of ways will be got by adding. So we shall add 2, 3, 3, 3 to get 11 ways. So what I wanted was this answer of 11 in this question. Then question 5 was about a magic square. So if the 5 by 5 square in the figure aside is completed with the letters A, B, C, D, E, so that no row, no column, or either of the 2 main diagonal lines contain the same letter more than once, which letter should replace the asterisk? So you need to get the letter which should be put here, which satisfies these 3 conditions: no row, no column, and not 2 main diagonals. So we have 5 letters A, B, C, D, E. We shall look for square by box so that we only have one option to fill that box. The first one shall start with is this, because if you look at this, if you look at the row, D and C are off. Then if you look at the column, E is off. And if you look at the diagonal, B is off. So it is only A. Therefore, you shall come and fill it with letter A. Then the next box will be this, because if you look at it here, D, C, D, and A are off. Then if you look at this, B is off. So the only option is E. So I'll come and fill there E. The next box will be this, because if you look at it, if you look at this, A is off, C, D, E are off. The only option is B. So I'll come and put B. The next will be this, whereby here B, C are off. Then E is off. And also here A is off. So you only have D. Therefore come and put D. Next will be this, whereby A, B are off, D, E are off. So the only option is C. So from there now I can get the letter they want here. Because if you look at this, A, B, C are off. Then if you look at the column, E is off. So the only option is D. So that is what they wanted. Then part B was on number theorem. Question 6 says, Scovia wrote down the numbers 26, 27 up to 209. How many digits did she write down? So these numbers have 2-digit numbers and also 3-digit numbers. The 2-digit numbers range from 26 up to 99. Then from 100 to 209, they are 3-digit numbers. So shall come and say that from 26 to 99, how do we get? I think you remember this formula. We saw it in the previous holiday. It says that you get the difference between the two and then you add +1 because these are also inclusive. So this minus this is 73 plus 1 to give you 74 2-digit numbers. What about from 100 to 209? So use the same formula, get the difference and add 1 to get you 110 3-digit numbers. But the question wants how many digits. So it means that the total number of digits will be 74 times 2 plus 110 times 3 to give you 478. Then question 7 says how many 6-digit numbers end in 2014. So it means that what is changing are only the first 2 digits, but the rest remain the same. Because only the first 2 digits are changing, it means where the first 2 digits will range from 10 up to 99. Just as you can see at 10, 11 up to 99. So how many numbers are those? We shall get together. We shall get the difference between the two and add 1 to get 96-digit numbers. Then question 8, the sum of 3 whole numbers taken in pairs is this and that. What is the middle number? So this one I also looked at it in the previous holiday. We shall let the numbers be in this form. So this is the smallest, followed by this, and followed by this. So when I add the first two small ones, I'll get 12. Then I add this one and this one to get the next value. Then the last two big ones, I'll get that value. Now I need to solve them simultaneously and get the value of x2. The first thing to do is to add everything. When I add all, I realize that I get 2 in brackets this. How? Because we have x, which is 2x, then x2, which is 2x2, then x3, which is 2x3. So that's where this 2 is coming from. Then these ones, when I add all of them, I'll come up with this. Simplify. The whole of this gives you 48. Then divide both sides by 2 to come up with here 24. Then there's something. If they want x2, I'll come here and look for a equation which doesn't have x2 and it is this. So it means that x1 plus x3 is equal to 17. Therefore, I'll come and substitute. Then get the value they wanted. That will be the middle number. Part C was on algebra. Question 9 says, let 2007 factorial plus 2008 factorial plus 2009 factorial be equal to this, where a and b are positive integers. Without using a calculator, find the pair AB. I think last day we covered factorials. So what do we say about factorials? If you look at these all values, the smallest is 2007, so it will be unaltered. Then 2008, we reduce it until we reach 2007. Then 2009, you reduce it until you reach 2007. Then you realize that it is common, the whole of this is common throughout. So put it out, factorize it out. Here to be 1, here to be this, and here to be the whole of this. Then you realize that this plus this gives you 2009. Okay. And also 2009 means it is common, so I can factorize it out. Here remain with 1, here remain with 2008. Then you realize that this plus this also gives 2009. So this times this will give you 2009 squared, which is similar to the expression given. That means that by comparison, A is 2007 and B is 2009. That's what they wanted. Then question 10. All but one of my math books are titled algebra. All but two, the first one says all but two of my math books are titled algebra. Then all but two are titled trigonometry. Okay, and all but two are titled geometry. I have at least one math book titled algebra. How many math books do I have? So yeah, the trick was on this word all but two. What does it mean? So suppose I have n books altogether. It means that n minus 2 of them are algebra. So that's what they mean by all but 2. It means of all of them, you remove 2. That's why there is minus 2. Then n minus 2 of them are trigonometry, and n minus 2 of them are geometry. Therefore, n is equal to 3 because we add all of them, this plus this plus this, to give you 3 in brackets n minus 2. Then you solve because this becomes a linear equation. Expand, then collect like terms and make the n the subject. So in total, I have 3 books. Then question 11 says, a man caught some fish. The 2 heaviest fish had a combined weight which was 25% of the total weight of all the fish. The 5 lightest fish had a combined weight, which was 45% of the total weight of all the fish. He put the 2 heaviest fish in the freezer and ate 5 lightest fish for lunch. His cat took all the remaining fish. How many fish did the cat eat? So the first thing to do is to let W to be the total weight, because there they said 25% of the total weight, which is here 25% times the total weight, which gives you 0.25 W. Then the lightest 45% of the total weight, which is 0.45 W. When I add this, I'll come up with 7, because 2 plus 5 will be 7. I have only one unknown, so I can simplify and solve it to get W as 10. Now that I have W, I can get the remaining percentage. Remaining percentage will be it will be W minus this plus that in brackets, which is 0.3 W. But the good thing, I know the value of W, so substitute to get 3 fish, which were eaten by the cat. Then part D was on geometry, and it says, given that O is the center of the semicircle, DB is 8, AB is 6, and BC is x. In the figure aside, find the value of x. So they want this value of x, meaning you need, because it's a right angle triangle, the only trick was to join this to this to get a right angle triangle, so that this distance can be used. So 1 from here to here, it is radius, also from here to here it is radius, and also from here to here it is radius. So I'll start triangle OBD, OBD. There I have this R, but I don't know OB. So can I get OB in terms of R? OB will be hypotenuse minus, OB will be the longest side minus one of the shortest sides, which is R squared minus 8 squared from Pythagoras theorem. Get a square root from both sides to get OB. So I've got OB in terms of R. Then first leave it there. Then I'll go to another triangle, OAB. So the good thing, I know OB and I know AB, so I can get OA. So let me do that. From Pythagoras theory, OA will be given by that. So substitute OB squared is this. Then AB is this squared. So you will come up with square root of that as the length of OA. Now I know OA, and I know that OC is R and CA is x plus 6, meaning I can get an equation there. So I'll come and say that from triangle OAC, I'll use Pythagoras theory and substitute R, then R squared minus 100, x plus 6 squared. So when you realize that this and this cancels, so here I remain with minus 100 plus this. So take this on this side to come up with this. Put square root on both sides, we'll come up with plus or minus. So next is to take this 6 this side to become negative 6 plus or minus 10. So there we shall get two values. One is negative 6 minus 10 to give you negative 16, and negative 6 plus 10 to give you positive 4. So we shall eliminate negative values and remain with a positive value. and that's what they wanted. So those were the solutions for the math contest, and now I'll leave you with an assignment on number theory. So that brings us to the end of this video. Thank you for watching, and bear in mind the next video will be on the solution to assignment 1. So if you have not yet subscribed, please click on the subscribe button of this video so you can receive updates when the next video has been uploaded. Hello viewers, welcome to Arena, taking you through the story for O-level math contest practice. And this video we're going to go through the solution to assignment 1 of week 1, which is under the section of number theory. So this video is suitable for students in O-level senior 1, 2, 3 and 4 with passion of one day participating in the national math contest. These are the questions I left, or the assignment I left in the previous video, and now we are going to go through them so that you can mark yourself and check your progress. So let's start with question 1. Question 1 says, it takes 852 digits to number the pages of a book consecutively. How many pages are there in the book? So these are digits. Digits and numbers are different. So 1, 2, 3, 4, those are digits. But when you reach 9 and you go to 10, it is no longer one digit. These are now 2 digits, 10, 11, all the way up to 99. They are 2 digits. Then from after 99, you'll go to 100. Those are now 3 digits, up to 999. So we are going to go step by step. Let's first look for pages which have only one digit. So from 1 up to 9, those are 9 digits because they have only one digit. What about from 10 to 99? We use the formula. I think by now you are aware of this formula. We have this formula shows the number of pages. So for example, from 10 to 99, how many pages are they? We use this formula. The difference between the two plus 1 gives you the number of pages from 10 to 99. But why are we multiplying by 2? It is because from 10 up to 99, there are two digits. That's why I'm multiplying by 2. So 90 pages times 2 gives you 180 digits. Now, so far, we have used how many digits? We have used 9 plus 80, which is 189 digits to number pages from 1 up to 99. What about from 100 up to? Now, if we say, for example, let's use the calculator and see. If I say 100 up to 999, it will even go beyond this number of digits. Because if I say 999 minus 100, I'll come up with 899. Do you see? So what we do is to get the balance of the digits remaining. So the remaining balance will be 852 minus 189 to give you 663 digits. Now these 663 digits, each page will have 3 digits. So we're going to divide to know the number of pages, which can be numbered. So the number of pages beyond 99 will be 663 divided by 3 to give you 221. Now these are the pages which should be labeled with three digits. Therefore, the total number of pages in the book will be 99, because from here up to here, we had stopped at 99. So 99 plus 99 pages plus 221 pages will give you 320 pages. And that's what they wanted. Then question 2 says, find the sum of all prime numbers between 1 to 100, 1 and 100, that are both 1 greater than a multiple of 4 and 1 less than a multiple of 5. Now here we needed some mathematics. I think you remember in algebra last holiday, we covered algebraic expressions. So let's see what they wanted. So let A represent the numbers between 1 to 100 which are 1 less than a multiple of 5. So 1 less than a multiple of 5, we shall come up with an expression. Because multiples of 5 are given by the expression of 5n, where n can be 1, 2, 3, up to 20. Now why do we stop at 20? It is because 20 times 5 gives you 100, which is our maximum. Okay, but they told us the numbers they want are 1 less than the multiple. So these are multiples of 5, then minus 1. These are the notations which I expect you to know by now, because in senior 1 we cover under sets, we cover such notations. Whereby when you put this dot, it means this is the expression, and you'll keep on substituting these values of n in this expression to get the elements in A. So let's now do that to get the elements in A. So when n is 1, it will be 5 minus 1, which is 4. When n is 2, it will become 9. N is 3, it is 14, all the way up to when you reach n equal to 20, which will be 99. Let's check. When n is 20, it will be 5 times 20, which is 100, minus 1 to give you 99. So I expect you to practice some patience and generate all those values. Then when you do that, we have now got these numbers, but those numbers are 1 less than the multiple of 5. What about this one of 1 greater than multiple of 4? Let's also get it. So let B represent numbers between 1 to 100 which are 1 greater than the multiple of 5. So we shall now use the formula. This is the multiple of 5, but they said greater than, so we shall say plus 1. Now why do we stop at 24? Let's check. 24 times 4, what does it give? 24 times 4, it gives 96. Now if we put 25, we're going to get something funny. 25 times 4 gives you 100. But they told you, but because of this plus 1, we cannot put 100, because 100 plus 1 will be 101, which is outside this range. So we have to stop at 24. Okay, so we are going to repeat the same procedure. Where there is m, put there these values here and generate the elements in B. So be patient and generate all those values. Okay, so now they told us they used the word and. In sets, I think they told you that the word and means intersection. So we need to get the intersection of these two sets, A and B. First, remember we have not yet dealt with prime numbers, we are just dealing with numbers. Be keen with that. So let's first get the intersection of A and B. So these are just numbers, they are not yet prime numbers. This will come last. So intersection, you realize that there is 9 here, then there is 29, then there is 49, then there is 69, then there is 89, that is the only intersection. But these are just numbers. So now that we have reduced the elements, we can now bring in the prime numbers. So let's see B prime numbers between this and this. It implies that A intersection B intersection C are the prime numbers we can get from the set A intersection B. So in this set, how many are prime numbers? You'll only get this and this, because this is not a prime number. This is not a prime number, and this is not a prime number. Okay, now that you have got the prime numbers, we shall go back. They said find the sum. So let's add those two. We shall come up with 118, and that's what they wanted. Then question 3 says, when 3430 is divided by the odd number n, the quotient is a positive prime number and the remainder is 0. What is n? So here there are some terms which we need to look at: quotient and remainder. Now quotient and remainder, what is it? For example, if I say 10 divided by 3, okay, what will I get in terms of mixed fraction? Mixed fraction, this will be 3 whole numbers 1/3. Okay, now what is the quotient? This is what we call the quotient, and this is what we call the remainder, and this is what we call the divisor. So now that we know what a quotient is and what a remainder is, we can start answering the questions. So one, we are going to first prime factorize this value. So prime factorize that. The first prime number is 2, so divide to get this. Next prime number is 5, divide to get that. Next prime number is 7, divide to get that. Then also 7, divide to get that. Then again 7, divide to get 1. So that is all. Therefore, expressing this as a product of prime numbers, we shall come up with 2 times 2 times 5 times 7 power 3. Okay, then you can start. The only way this can be written as to have an odd number and a prime number is this times this. Why? Because all these ones, it is true they are prime numbers. 2 is a prime number, 5 is a prime number, and 7 is a prime number. Okay, but if we want to get an odd number can never have a factor which is even. So if I say 2 times, let's try to test it, 2 times 5, it is equal to 10. The question is that odd? No. Why? Because it has a factor which is even. So for you to get an odd number, all the factors must be odd. Now the good thing, 5 is odd and 7 is odd. That is why we express it in this form. So that implies that n will be equal to this. And that's what they wanted. Then question 4. In what positive base x does the equation this for multiplication of base x numbers hold? Now here, they told you that these values are in base x, so your work is to write them in base x with these ones so that you can easily see them. Then you change them to base 10. So change this to base 10, change this to base 10, change this to base 10. Simplify. This is 4, this is x, this is 2, this is x squared, this is 3. Open brackets, it gives you that. There's a squared, meaning we have a quadratic. So let's first call it like terms, rearrange to get a quadratic. Now we have a quadratic equation, and there are two ways to solve it. One is by factorization, another one by using a quadratic formula. So by factorization, you look for two factors whose sum is -4 and product is 1 times -5, which is -5. So those two factors are -5 and 1, because if you multiply the two, you'll come up with -5, and if you add the two, you'll come up with -4. After getting those factors, replace this -4 with this sum. We call it splitting the numerator. So by splitting the numerator, it means the whole of this will be replaced with this, -5x plus 1. Then we factorize by grouping. Grouping means you look at these two terms alone and these two terms alone. So for the first two terms, x is common, so pull it out. Here remain with x, here remain with -5. Plus, here it is only 1, so just write x minus 5. Then again realize that this and this are common, meaning that the remainder will be x plus 1, which is here. Now, because it is equal to 0, we shall say that either this is equal to 0 or this is equal to 0. When we say x plus 1 is equal to 0, we get x equal to -1. When we say x minus 5 is equal to 0, we get x equal to 5. But they said positive base, so x cannot be -1, therefore x is 5. Then question 5 says a number capital M can be written as 47 in base x and as 74 in base y. Assuming that both x and y are positive integers, find the least possible value of x plus y. So here we are going to equate the two. 47 in base x is equal to 74 in base x is equal 47 in base x is equal to 74 in base y. Then we expand this to change this to base 10, change this to base 10. Simplify. This is 4x, this is 7, 7y, 4. Then you collect like terms, take this on this side, come up with that, then make x the subject. Okay, now when they told us these are positive integers, by integers we mean whole numbers. So I'm going to look for values of x and y so that we get both values of x and y which are whole numbers. Now if you look at this base, because this is 7, it implies that base x cannot be base 7 or below. It should be base 8 and above. Even here there is 7 here, meaning this base y is either base 8 and above. So we are going to start from 8 and onwards. Therefore, when y is 8, what is the value of x? You realize that x is a fraction, so it is not an integer, therefore this does not qualify. So y is not 8. Then we go the next. We shall keep on testing. When y is 9, substitute, you'll get a whole number which is an integer. So that means that those are the least values of x and y. X is 15 and y is 9. So the sum will be 15 plus 9, which is 24, and that's what they wanted. So that was the solution for the assignment 1. Now I'm going to leave you with assignment 2, still on number theory. So the whole of this week, we are going to do 5 assignments and all will be on number theory. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on solutions for assignment 2. So if you have not yet subscribed, please click on the subscribe button below this video so you can receive updates when the next video has been uploaded. Hello viewers, Wagdaruna taking you through the story for O-level math contest practice. And this video I'm going to go through the solutions to week 1 of the math contest assignment 2 for the year 2023. So this whole week the assignments will be from number theory. So question 1 said, what is the smallest positive integer which is divisible by all one-digit prime numbers but has no prime digits? So a value or a number which is divisible by a given set of numbers should be a multiple of their LCM. So if I'll come here, they told us one-digit prime number. The first thing to do is to list them. We have 2, 3, 5, and 7. So their LCM will be good by multiplying all of them to get 210. So all numbers which are multiples of 210 are divisible by each of these. So shall come here and list the multiples and identify the one which has no prime digit. This one has a prime digit 2, so it is off. This one has a prime digit 2, so it is off. This one has a prime digit 3, so it is off. But this one has no prime digit. Therefore, it will be the smallest number divisible by all prime numbers. Then question 2 said, what is the tens digit of the smallest 6-digit positive integer that is divisible by each of these? So still shall use the knowledge that the LCM of these multiples of the LCM of all these numbers are all divisible by each of these numbers. So for an integer n to be divisible by each of the 6 integers here, it means that n must be a multiple of their LCM. So the first thing to do is to get the LCM of these using any of the methods you know. But for me, to make it shorter, I'll first identify the prime numbers. So 11 and 13 are prime numbers. Then the rest, I'll have to prime factorize them. So prime factorizing 10 gives this, 12 gives this, 7 gives this, and 15 gives that. From there, you can now get the LCM, which will be 2, 2, 3. Okay, this 2 is scattered by this 2 is scattered by this, by any of this, but this 5 is not yet. So I'll come and put 5, I'll put 7, this 5 is already scattered by this 5, and this 3 is already scattered 4. So what is left will be these prime numbers 11 and 13. So when I multiply, I'll get the LCM as this 60,060. So all multiples of 60,060 are divisible by each of these numbers. So shall come and list all the multiples, because this one is 5-digit. If you look at it, 1, 2, 3, 4, 5. But the question wants 6-digit. So you have to get the multiples. So this multiplied by 2 gives this multiplied by 3 gives this multiplied by 4 gives this, and so on. So the good thing, we have already got a 6-digit number, which is here, and that will be the smallest 6-digit number. After getting the 6-digit number, we shall come and answer the question. The question said, what is the 10th digit of the smallest? So the 10th digit of this will be 2, because this is ones and this is tens. So we can conclude the 10th digit is 2. Then question 3, the 3-digit number, this 2A3, is added to the number 326 to give the 3-digit number 5B9. Given that 5B9 is divisible by 9, what is the value of A and B? In other words, you have to first get the value of A and value of B, then you add the 2. Now, in divisibility test, there's something they must have told you about numbers which are divisible by 9. So numbers which are divisible by 9, it means that the sum of their digits must also be a multiple of 9. So this one is divisible by 9, meaning that the sum of its digits is also a multiple of 9. In other words, it's also divisible by 9. Therefore, the sum is 5b plus 9, which is 14 plus b. Now, multiples of 9 greater than 14, the next multiple is 18, meaning that the whole of this sum is equal to 18. So I'll come and equate the 2 and then get the value of b as 4. I will now got the value of b, but I have not yet got the value of a. So I'll come and say that they told me that when this one is added to this, I'll be able to get this. So I'll come and substitute for b, and then take this on this side to come up with this. So if I compare, this 2 is here, this 3 is here, meaning this must be a. Therefore, a is 2. But the question wants the sum. Therefore, the sum will be 2 plus 4, which is 6. Then question 4 says, find the total number of 3-digit numbers that are divisible by 9 and contain no even digits. So still we shall remember the divisibility test for 9, that a number divisible by 9 is divisible by 9 if and only if the sum of its digits is divisible by 9. So we need to find 3 odd digits whose sum is 9 or 27. Now remember, we have skipped something. There is 9, multiples of 9, there is 9, there is 18, there is 27. But like I told you in assignment 1, an odd number can never have a factor which is even. If you look at this, it is, when you prime factorize, it will be 2 times 3 times 3. So because of the 2 which is even, it means this can never give us odd numbers. So the odd digits, from these odd digits, we shall look for digits whose sum is 9 and also digits whose sum is 27. And then we can, from those digits, we can get the possible 3-digit numbers. So first of all, we shall choose, if I add 1 plus 1 plus 7, I'll get 9. So that means that I can arrange these digits to get 3-digit numbers which is divisible by 9. So the first one will be 117, then 171, and 711. Another set of numbers are 1 plus 3 plus 5. It gives 9. So that means that I can rearrange these ones to get 3-digit numbers. So when I rearrange, I have 135, 153, 315, 351, 513, and 531. Then another set of numbers is 333. When you add them, you get 9, meaning, and there's only one way to rearrange, which is 333. Another set is 999. When you add them, you get 27, and the only number is 999. So when we count all those ones, we have, let's see, 1, 2, 3, okay, 4, 5, 6, 7, 8, 9, 10, 11. So the total 3-digit numbers are 11, and that's what they wanted. Then question 5 says, consider the positive integer p with representation p, which is 73961w. If p divided by 5 has a remainder 4, and p divided by 3 has a remainder 0, what is the value of w? So w is a ones digit. This is ones, tens, thousands, like that. Because some of you may confuse it to mean that it is this times w. It is not okay. It is a digit. So from the divisibility test, you must have realized that if a number is divisible by 3, then the sum of its digits is also a multiple of 3. So that means that if I have this number is divisible by 3, I will add all its digits. It should be a multiple of 3. So the whole of this is a multiple of 3. So the question is, which multiple of 3 is just greater than 26? The multiple of 3 which is just greater than 26 is 27, we have 30, we have 33, and so on. So those are the ones we shall use to test the ones which satisfy this other condition. Because already 27 is divisible by 3 and has a remainder 0. But the question is, will we get a remainder 4 when we divide by 5? When we divide this value of p by 5? So we need to get different values of w and see if the outcome is divisible, can be divided by 5 to get a remainder 4. So let's start. When the sum is 27, we shall get w as 1. When the sum is 26, we shall get w as 4. When the sum is 30, we shall get w as 4. When the sum is 33, we shall get w as 7. And when the sum is 36, because here from 33 we go to 36, we shall get w as 10. So this is not a one digit, so it is excluded. Therefore, the only options are these ones. So w can be 1 or 4 or 7. Okay, so this one can be replaced by any of the 3 letters. But there is another condition which was given. They say that p, when divided by 5, must have a remainder of 4. That means we are going to test for each value of w and see which one gives a remainder of 4. So let's do that. So when w is 1, here we'll replace this w with 1, and when we divide we get this remainder 1. So this is not okay. W is not 1. What about when w is 4? Replace the w with 4, you get a remainder 4, which is okay. Let's also test for the other one to be sure. When w is 7, we get a remainder 2, which is not okay. So the only correct value of w is 4. Therefore, we can now say that w is 4, and that's what they wanted. So still, like I've always done, I'll leave you with an assignment. Still on number theory. that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on solution to assignment 3. So if you have not yet subscribed, please click on the subscribe button below this video so you can receive updates when the next video has been uploaded. Hello viewers, Daruna taking you through the story of O-level math contest practice. And this video we're going to go through the solutions to week 1 assignment 3 for the year 2023. And this assignment is under number theory. So we shall start with question 1. Question 1 says a prime is a prime number that yields a prime when its units digit is omitted. Units digit is a digit in ones position. For example, if you see 317, when I remove the units digit, which is 7, I remain with 31, and this 31 is also a prime number. So that's what they mean by prime number. Now the question is, how many 2-digit primes are there? So for you to answer this, you are going to list all prime numbers from 1 up to 99. Sorry, from 10 up to 99, because 2-digit numbers range from 10 up to 99. So you have to be patient and list all of them. So those are the ones we have. Now we go back to the definition. It says when you remove the one's digit, you remain with a prime number. Remember, when you remove one digit from a 2-digit number, you remain with only one digit. So what to do? Remember that prime numbers which are 1 digit, we have 2, we have 3, we have 5, and we have 7. So in this list, we are going to look for numbers which start with 2, 3, 5, and 7. Those are the ones we are going to remain with, and the rest we are going to first remove them. So you remove the whole of this, then remove here 3, we need it. Remove the whole of this 4, 5, we need it. We remove the whole of this 6, 7, we need it. Remove the whole of this 8 and the whole of this 9. So what are we left with? We shall remain with 23, 29, 31, 37, 53, 59, 71, 73, and 79. So those are the 2-digit primes which we have. Now they said how many, so you have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore you will conclude that there are 9 2-digit primes, and that's what they wanted. Then question 2 says, prove that if 3 consecutive integers are multiplied and the middle number is added to the result, the number obtained will always be a cube. So you have to let a middle number be x. If there are 3 digits, 3 consecutive numbers, then the middle one is x. It means the one before it, remember they are integers, the one before it will be x minus 1. What about after it? It will be x plus 1. So they said you multiply all those 3. So we're going to multiply all those 3 this is the product. Then they told us you add the middle number. So you add the middle number on the product. So this one gives you this when you rearrange. Then from there, realize this one is a product coming from difference of two squares, because one bracket is difference, another one is sum. I think you remember that in the section of algebra. So difference of two squares, we shall come up with x squared minus 1 here. Then there is another, this x here, and also this x. Then again, we open this bracket, you will come up with x cubed minus x plus x. Okay, now here you realize that this and this can cancel and you remain with x cubed. And remember, x cubed, x was the middle number, so we have proved what they wanted. Then question 3 says, when the decimal point of a certain positive decimal number is moved 4 places to the right, okay, the new number is 9 times the reciprocal of the original number. What is the original number? So you will let the original number be y. Now they said the decimal is moved 4 times to the right. 1, 2, 3, 4. Do you know what that means? It means the original number was multiplied by 1000. That is the only way you can move a decimal 4 times to the right. If it was to the left, then it would be divided by 10,000. But because they say to the right, it means we multiply by 10,000. So that means that the new number, after moving the decimal, we shall multiply the original by 10,000 to get the result. Okay, then they told us something, that this new number is 9 times the reciprocal of the original. Now reciprocal means 1 over something. For example, if it was y, the original number was y, now the reciprocal will be 1 over y. But they didn't talk about only the reciprocal, they also talked about this 9 times. So you multiply this by 9 and equate it to this new number. So when you do that, we shall come up with this expression. Okay, now they said, what is the new number? What is the original number? When they ask for the original number, they want the value of y. So our aim is to look for a way of making y the subject. One, we are going to cross multiply. Take this on the side to come up with this. Then this is like over 1, so 1 times 9, it gives you 9. Then you divide throughout both sides by 10,000. There is a square here. To remove it, you put square root on both sides. You'll come up with this, and when you use a calculator, you'll come up with this, which is the same as 0.03. So the original number was 0.03. Then question 4 says, student lockers at a university are numbered consecutively, beginning with locker number 1. Okay, the plastic digits, note this word, there's a difference between number and digit. I think by now you know the difference. The plastic digits used to number the lockers cost shillings 200 each. Okay, if it costed shillings 1,390,600 to label all the lockers, how many lockers are there at the university? So the first thing to do is to get the number of digits, because each digit is for this, but they use the total of this. So when I get this total divided by the amount for each digit, I'll be able to get the number of plastic digits used. So the number is 6,593 digits, which were available to make the lockers. Okay, now let's see. The locals are numbered 1 up to somewhere where you don't know. So from local 1 up to local 9, they used 1 digit. So it requires only 9 digits. Okay, what about from local number 10 to local number 99? We use this formula. I think by now you're conversant with it. This minus this plus 1 gives you the number of locals there, which is, but they said, sorry, number of digits, then times 2. So these are the number of locals, but each local has 2 digits. So that's why I multiply by 2 to give you 90 times 2, which is 180 digits. Okay, now so far we have used 9 plus 180, which is 189. Let us go to 3-digit number, locals. So from 100 all the way through to 999, how many digits are there? We shall first get the number of locals, which is this minus this plus 1, which is this, but each local has 3 digits. That's why I multiply by 3. You will come up with 2,700 digits. Okay, now let us first find out the number of digits you have used so far. So far we have used 9 plus 180 plus 270, which is 2,889 digits from local 1 up to local 999. So how many digits are remaining? The remaining digits will be this total minus the one used so far to give you 4,064 digits. Therefore, the extra number of locals beyond 99 will be this divided by 4, because there will be now 4 digits after 99, after 999, which gives you 1,016 locals. Therefore, the total number of locals will be 999 plus 1016, which gives you 2015 student locals. And that's what they wanted. Then question 5, it says James has a 3-digit code for a padlock. Okay. He has forgotten the code, but he knows that if you divide the first digit by the second digit and then square the result, you get the third digit. This is a little tricky, but you have to go slow. How many 3-digit codes have this property? Show your working. So one shall say, let the 3-digit code be ABC. This is the first digit, second digit, third digit. Okay, then they say that what he knows is that if you divide the first by the second, first divided by second, you get A over B. Okay, and then square the result. So that is A over B, everything squared. You get the third digit. It will be equal to C. Now let's first write it mathematically. The third digit is that, but it's squared, which is squared. Therefore, it means that the third digit can be any of the following. It can be this division can be equal to 1. There the third digit will be 1 squared, which is 1. Okay. Then also this division you can divide and get 2. So the third digit will be 2 squared, which is 4. Or the division can be equal to 3. There when you square you get 9. Now why did we stop at 3? Because if you proceed and get 4, 4 squared is 16. But 16 is a 2-digit number. So we can't proceed. The only option is this. So C, we have now seen that the third digit can either be 1, or it can be 4, or it can be 9. Now what we are going to do, we are going to analyze each of these 3 digits. So let's start with 1. If the third digit is 1, do you know what it means? It means that this A over B is equal to 1, meaning that A is equal to B. Now the question is, how many pairs can we get which are equal? We can get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. So it means that B ranges from 1 up to 9. But if you want to list them, they didn't tell us to list, but you can list them for you to analyze it. So the first and second digit will be the same, 1, 1, then you add this 1. Then 2, 2, then you add this 1. 3, 3, then you add this 1. 4, 4, you add 1. 4, 4, you add 1. 5, 5, you add 1. 6, 6, you add 1. 7, 7, add 1. 8, 8, and 9, 9, add 1. Okay. So the question didn't tell you to list them, they just asked for how many. So it is okay. If you get this, you can just say 9 minus 1, everything plus 1, which gives you 9, because our interest is this 9. But that is for the first option. Now, what if the second digit, the third digit was 4? How many codes do we have which end with 4? So we shall come here and say that if it is 4, it means that A over B is 2. Let us do it here. A over B is 2, meaning that A is equal to B. Now, which pairs do we have which give that? So it means that B ranges from 1 up to 4. Do you know why? It is because if you exceed 4, you are going to get 5. But remember, A is 2B, so 2 times 5 will give you 10, which is a 2-digit number. Yet for us, we want 1 digit. That is the reason why we stopped at 4. So here still, you could use the knowledge that this minus this plus 1 to give you a number of codes. But if not, you can list them. So if we are to list, we shall get these ones, where A is twice, so 2, 1, 4, 2, 6, 3, 8, 4, like that. Then the third option is when the third digit is 9, meaning that A over B is 3, so A is 3B. There, the values of B will stop at 3. Do you know why? Because if we go exceed and go further to 4, 4 times 3 will give you 12, which is a 2-digit. So, how many digit codes are there? It will be this minus this plus 1. And those are 3 possible codes, but you can list them if you want. So the question is, how many in total that we have to add? Remember, the first one option was 9, second option is 4, third is 3. So in total there will be 16 codes, and that's what they wanted. So now I'll leave you with assignment 4, still on number theory. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on solutions to assignment 4. So if you have not yet subscribed, please click on the subscribe button below this video such that you can receive updates when the next video with the solutions has been uploaded. Hello viewers, welcome Daruna taking you through the story for O-level math contest practice. And this video we're going to go through the solutions to week 1 for the math assignment 4 for the year 2023. So the assignment is under number theory. So question 1 says, in the subtraction below, A, B, and C are digits, and A is less than B. Then what is the value of C? So this is the subtraction they are talking about. Now here we need to remember the primary subtraction. If you had a number like 94 and here we have 883, just an example, because they told us, the reason why I'm choosing this is because they told us that A is less than B. Yet here you have a B, so this one up should be smaller than the one down. So how do you do it? The first thing you would do, because this is smaller, you would borrow 1 from here. So this remains 8, and this becomes 14. Then you could say 14 minus 8 to give you 6. Then I would say 8 minus 3 to give you 5. So what have we done? When we borrowed 1 here it became a tens. Remember, this is in position of tens, so it has to become 10 plus what is here, which is 4. So that means that if we come and borrow 1 here it will become 10 plus A. That's what I wanted you to see from this example. Then what about this remainder? After borrowing 1, what happens? For this one, it is just less by 1, so it will become B minus 1. Okay, so with that idea, we can now do our subtraction. Remember, this is smaller than this, so by all means, we have to borrow. So you'll come and borrow 1 from B and bring it this side. So when you bring it this side, it becomes 10 plus A. I think you remember that, because this what we are borrowed is in position of tens. So when we borrow 1, the balance here will remain B minus 1. So shall come and say this is B minus 1. Then with that, we can now do our subtraction. So it will become this minus this gives you this. Okay. Then this minus this gives you that. So let's write that down. On subtraction, you shall get this, which is here, minus B, which is here, gives you 6, which is here. And when we rearrange, take this one this side, we will come up with A minus B equal to negative 4. What about this other one? It will become this minus this will give you that. So rearrange, you take this one this side, you'll come up with B minus A equal to 1 plus C. Now when you realize this, when you look at this, you realize that when I add the two equations, A and B will cancel, because when I add this will cancel with this and this will cancel with this. So that's why you put 0 here, and here we shall remain with this plus this, which is here. Now the good thing, we only have one unknown, which is C, meaning we can get the value of C. And that's what they wanted in the question. Then here, question 2, the number this 102564 has the property that if the last digit is moved to the front, the resulting number, namely this, so realize that the first one's digit was moved to the front, you'll come up with 410256, is 4 times larger than the original number. In other words, this new value will be equal to 4 times the original value, original number. Then they asked, Find a 6-digit number whose last digit is 9 and becomes 4 times larger when we move this 9 to the front. Okay, now here we need to let. Remember they told us it's a 6-digit, but it ends with 9. But we don't know the first 5 digits. We only know that the last digit is 9. Therefore, we shall let the first 5 digits be A, B, C, D, E. So this will be the 6-digit number. These are the first 5 digits followed by the last digit, which is 9. Now they have told us when you move this 9 to the front, what we get will be 4 times this original number, just as we had seen in this example given. So we shall come and say, we need to find the digits, these ones, such that when you multiply by 4, you'll come up with this new value. So this is the original value, multiplied by 4, you get the new value. Okay, now still this is primary multiplication. And let us start. To multiply, I think you remember we did value by value, but we'll start from ones, tens, and so on. So we are going to first start by multiplying this and see what we get. So when you multiply 4 by 9, you get 36. Now, do you know what you're going to do? The 6 here is what you put here in the position of ones. Then this 3 is in tens, so it will go and be added to this value in the position of tens. So let's do that. So it means that E is 6, because that's what it will be here, 6, and we carry 3 to the next position. So let's come and remove this 3, this E, and put there 6, and then here on top we put a 3 to help us remember that we are going to add. Then we have after this, the next is to multiply these 2. Then after multiplying, you add on this one which you had carried. So we shall come out that, you know what that means? It means that 4 times E plus 3 gives you D. Let's write it here. 4 times E plus 3 is equal to D. But remember, we know the value of E. So when I substitute for E, I'll come up with the value of D being given by 27. But we can't write 27 in this position. Do you know what we're going to do? We are going to write 7 here and then carry the 2 to the next place value. Therefore, D is 7 and we carry 2. So let's come out where there is D, we shall remove it and put there 7. Then we bring the 2 here. Okay, we are done with this, we are done with this. Now the next is this 4 times E times D plus 5 plus 2, what will be equal to C. So let's write it. 4 times D plus 2 is equal to C. But we know the value of D. So come and substitute for D, you'll get C as 30. But you can't write the whole 30 here. So what you're going to do, you're going to write a 0 here, then you carry this 3 forward. So let's come and remove the C and put there 0, then carry the 3 forward. Okay, so that is it. But since the slide is done, let's go to the next slide and complete the multiplication. So this is exactly what we have, where we had stopped so far. If we go back, you should realize that it is the same step here. I've just recopied it so that I can complete the multiplication. Now next is to multiply 4 by C. What you get, you add 3. And with that, you'll be able to get the value of B, which is here. So substitute, remember we know the value of C, C is 0, so we come up with 3. Now this 3 is only in the, we have nothing to carry, so we shall just write, because there's one digit where there is B, we shall put there 3, and we carry nothing, so here we shall just put 0 to make the procedure consistent. So remove B and put 3, then here you carry 0. So now next it will be 4 times B plus 0 will be equal to A. Then we can come and write 0, which is this, plus 4 times B equal to A. I know the value of B, so I'll substitute for B and get 12. So this 12 means I'll write 2 here and carry 1 here. So let me first complete, put 2 here and carry 1 there. Here it should be 1. It's a mistake, put 1 here. So we have got now all values A, B, C, D up to E. And now we can quote the 6-digit number which they wanted. So A is this, actually it is here. A, B, C, D, E is there. Then put the 9, end with a 9. And that's what they wanted. That was question 2. Then question 3 says, a number system based on 26 uses the letters of the alphabet as its digits, with A that, B that, C that, up to Z 25. Express 0NE plus 0NE in this system. Now this, we have been used to bases, base 5, base 6, but now this is base 26. The first thing to do is to come and draw a table which converts the alphabet to numerals. So A is that, B is that, C, D, E, F, G, H, I, J. Then we proceed K, L, until we reach Z. So each letter is represented by that number. So I think to realize that in base 26, the last digit should be 25, which is there. Then we can come and get the output they want. So 1 plus 1. The first thing to do is to add these ones. But remember, we are in base 26. So E plus E, we shall come on our chart and look for E. E is 4. So 4 plus 4 gives you 8. Then we come and say, where is 8? 8 is here. Meaning that we put I. That is why you see I here. Therefore, I'll come here in this column, in this part 1, position of ones, I'll put I. I've not borrowed anything, I've not carried anything forward. Then I'll go to next, which is capital N plus capital N. N is 13. So N plus N will be 26. But remember, we are in base 26. So we can't write 26. Do you know what we are going to do? We shall enter 0 and carry 1. So 0 and carry 1, but our 0 is A. And carry 1 to this part. So come and write your capital A here and also write the 1 there. The next is to add 1 plus O plus O. What is O? O is 14. So I'll come and add 1 plus O plus O, which is 1 plus 14 plus 14, which is 29. But remember, we are in base 26. That means that we are going to enter 3, which is D. So come and put D there. Then what happens this to the 1 which you shall carry forward? The one we shall carry forward will be, if you come here, it is B. because there's no other things to add here, then we shall just put it in the next place value, which will be that. And actually that is what they wanted. Then question 4, in the sum below, letter F is 0 and the other letters represent digits 1, 2, 3, 4, 5, or 6, with each digit used exactly once. Exactly once. Okay. The 2-digit integer AB is a prime number. What is the value of A plus B? Now this is a 2-digit integer. This is in place value of 1s and this is in place value of 10s. What we are going to do, we are going to first list down all the 2-digit integers. Sorry, all the 2-digit prime numbers which are less than 70. Now, why have we said 70 of all? It is because the digits are up to 6. So if we go to 70, 80, that will be already beyond the 6 we are interested in. So let's first list down the prime numbers up to less than 70, which don't go beyond 70. So we have to list them patiently, and those are the ones. Okay, now we are going to do some elimination because they told us we only want digits 1, 2, 3, 4, 5, 6. But here realize there's a digit of 7, digit of 9, digit of 9. Here there is some 7, there is some 7, there is some 9, there is some 7. So all those ones with digits beyond 6 are going to be eliminated. So what are we going to remain with? We shall remain with these prime numbers: 11, 13, 23, 31, 41, 43, 53, 61. Okay, we are on track. Remember, our addition is here, that FB plus CD will give you EFG. But the good thing, we already know F. Now let us start. From the above list of prime numbers, B is either 1 or 3. If you look at these prime numbers, the ones digits, there is 1, 3, 3, 1, 1, 3, 3, 1. So that means that this one can only be 1 or 3. It can't be 2, it can't be 4, it can't be 5, it can't be 6, based on this list we have. Okay, that is known. Then also another thing we need to realize is that from our list, the sum of any two numbers cannot exceed 11. If you look at this list, the biggest will be this one, but it is 11. It can't go beyond that. So it means that if I add these ones, remember when you add when I add these ones, I'll get a 2-digit number, and that 2-digit number, the tens place value will take that position, and the ones will take this position. Now, because when I add, I can't get 20s or 30s or 40s, it means that this one, it must be 1. Okay, now because it must be 1, what happens? It means that now we know that this is 1 and this is 0. Okay, because that is it, and we had seen earlier that B is either 1 or 3, and 1 has been taken by E. It means that B, the only option for B is 3, which is there. So we have also got the value of B, which is 3. Okay. So what will be the remaining prime numbers which end with a 3? So this will go away, this will go away, this will go away, and this will go away. So we are going to remain with 13, 23, 43, and 53. Okay. So now our addition, we have this. So we have got E, we have F, and we know B. So of the remaining digits, we have now 2, 4, 5, and 6. Since D cannot exceed 6, it implies that the sum B plus D, which is this, will be less than 10. So it will be a 1-digit number. So that means that A plus C was 10. I think we already saw that. So from the remaining digits, the pair which gives a sum of 10 is 6 and 4. So that means that this plus this to be equal to 10, you only have one pair which is 6 and 4. So that means that if A is 4, C will be 6. Or if A is 6, C should be 4. In other words, A can either be 4 or 6. Now, what is the value of A is what we want to find out. So from the remaining prime numbers will now be this. Now, how have we eliminated? We shall come here. Remember, AB was a 2-digit prime number, and we had a list that prime numbers which end with 3 are these ones. Now, if the first digit should either be a 4 or a 6, we shall come here and realize that there is no 6, but there is a 4. So these ones which are not 4s shall be eliminated, and we have only one figure, which is 43. That means that by all means the value of A is 4, and the value of C will be 6. Okay, good enough. In our question they ask for the value of A and B. We have got the value of B, and we also have the value of A, so we can add the two. So when you add, we shall come up with 7, and that was the required sum. Question 5 says, if this is a 4-digit number such that this base 5 plus this base 7 is equal to this base 8, what is the value of the digit capital N? So these are different bases. So the first thing to do is to convert all of them to base 10. So this to base 10 gives you this. This to base 10 gives this. And this to base 10 gives that. Then you can now substitute when they're in base 10. So this to base 10, this to base 10, this to base 10. Then we collect like terms. So this plus this gives this, this plus this gives this, this plus this gives that. Rearrange, when I put n this side, it will become 1n. Then put this on this side, become this, and this on this side to become this. So I have an equation having n, t, and e. Now because the smallest base is base 5, and all these digits are the same throughout, it implies that each of these letters have values which are less than 5. So it can be 0, 1, 2, 3, or 4. Then another thing is that this first digit can never be 0. 0 can either be in between but not here. So that implies that t can never be 0. Because first of all, you can even see it from here that when t is 0, you'll get a negative value of capital N. That is 1. Then 2, you realize that if t is equal to 2 or 3 or 4, it implies that the value of n would be greater than 4 for e less than 5, which would be a contradiction. Let's try to see what I mean. In this expression, if I put, for example, 2 here, I'm going to get 2 times 4, which is 88. Okay, then minus. Here I can put any other value. Let me put, say, if I put 0 here, it will be 88 minus 0, which is too big, yet n should be less. If I put e equal to 1, it will become 88 minus 28. Still it is big. If I put 3 here, it will become still above 4. Let me just see here, calculator. 14 times 3, 14 times 3, it gives you 42. That means that 88 times minus 42, it is still big. So in short, the value of t, the only option for value of t is 1. So we are going to test for the different values of e. So if t is already 1, e can take digits of either 0 or 2 or 3 or 4. So let's start testing. When e is 0, what happens? Put the 1 here for t and 0 here for e. You will get 44, which is too big and it's impossible. Then go the next. 1 here for t and 2 for e. You will get 16. It is also impossible. Then go the next. 1 here for t and 3 for e. You will get 2, which is okay. But let's complete our values. So 1 and 4. Put 1 here for t and 4 for e. You'll get a negative. So the only true option is this. And in this, realize that t is 1, e is 3, and n is 2. So you can conclude that t is 1, e is 3, and n is 2. So the value they wanted was the value digit for n, which is 2. So now I'll leave you with an assignment. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on assignment 5. So if you have not yet subscribed, please click on the subscribe button below this video so you can receive updates when the next video has been uploaded. Hello viewers, Wagadaruna taking you through the tutorial for O-level math contest practice. And this video I'm going to go through the solutions for week 1 of assignment 5 for the year 2023. So this assignment is under number theory. So now we shall start with question 1. Question 1 says, how many of the 2-digit numbers between 10 and 99 inclusive have the property that both are perfect squares and do not start with a 4? So first of all, you know that digits which are perfect squares, we have 0, 1, 4, and 9. Therefore, now we are going to list all the digits, 2-digit numbers which can be got from these 4 digits in ascending order. So we have 10, 11, 14, 19. Then 40, 41, 44, 49. Then 90, 91, 94, 99. So those are the 2-digit numbers where both digits are perfect squares. Then you shall exclude those which begin with a 4. So you shall remove this, 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 and this. The remaining ones will be that. Then you shall count them. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. And therefore shall say that, because the question said how many, so you have to end by saying there are 8. There are 8 2-digit numbers. So yeah, you add the word 2-digit. 8 2-digit numbers that have the property that both digits are perfect squares and do not start with a 4. Then question 2 says, let Pn and Sn denote the product. So P is for the product and S is for the sum, respectively, of the digits of a positive integer capital N. For example, if we have P63, it means that P is the product of 6 times 3, which is that, and gives you 18. Then when we say AS63 means S will be the sum of 6 and 3. So they said find all 2-digit numbers for which capital N is equal to Pn plus Sn. So shall let the 2-digit, let capital N be AB. So A, B, it means this is in position of 10, that's why we write 10 times A. This is in position of 1, so it is B times 1, which remains as B. So here A and B are digits. Therefore, it implies that their product, the product of this 2-digit number, is A times B, and the sum is A plus B. Then they told us this, they gave us this condition. So we're going to come and set the condition. Then we can substitute. Capital N, we put there this, product, and sum, like that. Then we can collect like terms. First of all, this B and this B can cancel, so remain with this. Then this can come this side to come up with that. Then here, this A can cancel because it's on both sides to remain with B as 9. So do you know what that means? It means that the numbers must have the second digit as 9. So what are those numbers? The numbers will have 19, 29, 39, 49, 59, 69, 79, 89, and 99. And that's what they wanted in this question. Then question 3 says the number of fish that swam with me is the sum of the digits of the largest integer x, which satisfies the inequality this. So the question is, how many fish swam with me? So this has some algebra. The first thing to do is to cross multiply. So we are going to treat this in quite as if it was an equal sign. So first cross multiply to come up with this, then open this bracket to come up with this, then collect like terms, take this one this side. So x has values less than 2008. Therefore, the maximum value of x will be 2007, because from 2007 you go to 2008, but this x is less than 2008. So the number of fish that swam, they told us here that the number of fish that swam with me is the sum of the digits of the largest. So this is the largest digit. Therefore, the sum of the largest value, so the sum of the digits will be 2 plus 0 plus 0 plus 7, which gives you 9. And that's what they wanted. Then question 4 says, capital A, is a 2-digit whole number that does not contain 0 as a digit. Then capital B is a 3-digit whole number and a% of B is 400. Find all the possible values of A and B. So one, we know that a% of B is equal to 400, therefore A over 100 times B of means multiplication is equal to then 400. So A times B gives you, cross multiply to give you 40,000. And this A times B can, if you prime factorize this, we come up with 2 to the power 6 times 5 to the power 4. Now, since A is a 2-digit number that does not contain 0 as a digit, it means that A cannot have both this and this as a factor. Why? Do you know why? Because 2 times 5 gives you 10, and this 10 has a 0 digit. So A cannot have both factors of 2 and 5. And for A to be a 2-digit number, A should be 2 to the power 4 or 2 to the power 5 or 2 to the power 6. Why? Because if I said 2 to the power 1, it gives me 2, which is 1 digit. If I said 2 to the power 2, it gives me 4, which is 1 digit. If I said 2 to the power 3, it gives me 3, which is 1 digit. But when I said 2 to the power 4, it gives me 16, which is 2 digit. That is why I've said it's either this or this or this. We stop at 2 to the power 6 because of this. But also remember that B is a 3-digit number. So we shall test for the various products until we get where A is a 2-digit and B is a 3-digit number. So let's start with the various ways. So if I put 2 to the power 4 here, I remain with 2 to the power 2 because the total should give me 2 to the power 6. So 2 to the power 4 is A and B is 2 to the power 2 times 5 to the power 4. When I use a calculator, 2 to the power 4 is 16 and this is 2,500. When you count, these are 4 digits, so it is not true. What about when I use now 2 to the power 5? Here I remain with 2 to the power 2 and 5 to the power 4. Using a calculator, this gives me 32 and this gives me 1250. It is still impossible because these are 4 digits. Then we go to the next. When I use 2 to the power 6 and 5 to the power 4, I'll come up with 64 here and 65 here. So this is true because this is a 3-digit number and this is a 2-digit number. Therefore, A is 64 and B is 265. That was question 4. Now question 5 says, what is the units digit of 2 to the power 2017? Now, if you press a calculator and feed this in, you will realize that you get a math error because the number is bigger than what the calculator can accommodate. Therefore, what you're going to do, by what the calculator can accommodate, I mean the calculators you are using, because there are some more advanced calculators than the ones you are using. But based on what with the calculators you have, then this value will be a math error. And if it's not a math error, then to give your answer in scientific notation, whereby the last digit cannot be known because it will be rounded off. So what do? We have to analyze the patterns of these powers. Then we come up with a conclusion. So if you look at 2 to the power 1, the 1's digit is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. And in that, the unit digits of this is 2, 4, 8, 6. Let's go to the next 4. 2 to the power 5 is 32. 2 to the power 6 is 64. 2 to the power 7 is 128. 2 to the power 8 is 256. Do you realize something? The 1's digit is not changing. Here it was 2, even here 2, 4, even here 4, 8, even here 8, 6, even here 6. But before we conclude, let's also do for another set. 2 to the power 9 is this, 2 to the power 10 is this, 2 to the power 11, 2 to the power 12. Now you'll notice something also. 2, 2, 2. Okay. 4, 4, 4. Okay. 8, 8, 8. Okay. Then 6, 6, 6. So that is helpful because we shall be able to find out the unit digit for the value of 2 to the power 2017. So is what I've been talking about. The order through is the same. Therefore, when the exponent is multiplied by 4, or when it's a multiple of 4, the unit digit will be 6. Because here, this was 4, 8 is a multiple of 4, 12 is a multiple of 4, and all the unit digit is 666. Therefore, it means that the nearest year to this, which is divisible by 4, will be 2016. And that 2016, it means that 2 to the power 2016 has the unit digit as 6. Then from 2016, you go to 217, where the unit digit will now be at 2. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on indices, surds, and logarithms. So if you have not yet subscribed, please click on the subscribe button below this video so you can receive updates when the next video has been uploaded.